Hello guys. Today we start to study chapter 3, Energy. This chapter contains 13 sections, divided into 4 parts. We will learn about work, energy, momentum, and Einstein's spatial and general relativities. Energy is the ability to accomplish a change by force. To describe the change by force quantitatively, we need to introduce a new quantity called work. Work can be simply defined as a measure of change by a force produces. For force F to move an object to cover distance d, the work done by the force is W equal Fd, F times d. Work is a scalar quantity, and its unit is joule, shortened by J, with 1 J equal 1 Newton meter. To lift an object to height h, a force is needed to do work against Earth's gravity. The applied force at least equals the gravity or the weight of the object, mg. Therefore, the work done against gravity can be calculated by W equal mgh. It should be noted that the work done against gravity does not depend on the particular road taken by the object, only depends on the height and the mass. Here g is the gravitational acceleration, learned before, which is equal 9.8 meter per second square. Power is a quantity to describe how fast to do work. It can be simply defined as the rate of doing work, or work done per unit time. Power equals work done divided by time, P equal W over T. The more power something is, the faster it can do work. Power is also a scalar quantity, and its unit is joule per second, which is defined as a new name called watt, shortened by W, with 1 W equal 1 joule per second. 1 kW is, that's kilowatt, is 10 to the 3 watt. Another power unit is called horsepower, HP, which is equivalent to 746 watt. For example, the power of a garage opener is 1/3 horsepower. Now we can say energy is the ability to do work. There are many types of energy. Energy of motion is called kinetic energy. For a moving object, its kinetic energy is calculated by half m v squared. M is the mass of the object, v is the speed of the object. The unit of energy is the same as work, joule. For example, find the kinetic energy of a 10 kilogram object moving at 2 meters per second. From the kinetic energy formula, substituting mass as 10 kilogram, speed as 2 meters per second, we have kinetic energy equals half times 10 times 2 squared equals 20 joule. Energy of position is called potential energy. An object with mass m and height h possesses potential energy given by mgh and called gravitational potential energy because it's related to the force of gravitation. When you lift an object to height h, you need to do mgh work against the gravity. Due to the work done, the object gains mgh gravitational potential energy. Potential energy is relative because the position or height is relative. For example, find the potential energy of a 10 kilogram object with height 100 meters. From the potential energy formula, substituting mass as 10 kilogram and height as 100 meters, we have potential energy equals mgh equals 10 times 9.8 times 100 equals 9800 joule. Section 4 is about conservation of energy. Energy exists in nature in many forms such as kinetic, potential, heat, chemical, radiation, nuclear, and so on. All forms of energy can be transformed or converted from one to another. For instances, the pendulum's back-and-forth motion transforms its energy between potential energy and kinetic energy. A lighting bulb converts electric energy into heat and radiation. Light is a radiation. The transformation of energy does not destroy or create energy. Energy is conserved. The law of conservation of energy can be stated as energy cannot be created or destroyed. It can only be changed from one form to another. Based on this law, we can simply find the speed of pendulum at any position. For example, find the speed of the pendulum at the lowest point. Pulling a pendulum with mass m and length l away from the vertical by angle theta to the highest point, position 1. Releasing it, then the pendulum swims down to the lowest point. The speed of the pendulum at the lowest point can be obtained based on the conservation of the energy, i.e., the kinetic energy plus potential energy at the highest point, Ke1 plus Pe1, equals to the kinetic energy plus potential energy at the lowest point, Ke2 plus P2. At the highest point, the pendulum has only potential energy without kinetic energy because of no speed. At the lowest point, the pendulum has only kinetic energy without potential energy because of no height. Therefore, we have, according to the energy conservation, mgh equals half mv squared. Cancel the m from both sides, multiply 2, then square root. We can find the speed of pendulum at the lowest point, v equals square root 2gh. Well, h can be obtained by L minus L cosine theta. Then we have the speed equals square root 2gl 1 minus cosine theta. This speed cannot be easily found from the motion we learned from chapter 2, like a circular motion, because this speed is not uniform. It's changed. Also two-dimensional motion. But based on the conservation of energy, we can find this speed very easily. The next section talks about mechanical advantage, MA. The mechanical advantages of a system is a quantity defined as the ratio between the output force and the input force. The system with MA greater than 1 can save the force, but not the work done. For some examples, levels, pulley systems, inclined planes, and so on. Nature of heat. What is heat? Heat was once thought to be a weightless, invisible, colorless, and tasteless substance called caloric. But in 1843, James Prescott Joule related heat to work, and therefore concluded that heat is a form of energy. Joule made this conclusion based on his famous experiment. That's the Joule experiment. Joule experiment consists of a receptacle filled with water, a thermometer to measure the water temperature, and a pulley system with spinning plates and a falling object. The experiment results show when the object falls, the plates rotate and disturb the water, and in the meantime raises the temperature of the water. This implies that the potential energy, i.e. work done by gravity, released from the falling object, can be converted to the heat of water. Therefore, heat is a form of energy. Thanks for today. We will continue next time. See you.